Hello, my name is Derek Strickland. I'm an engineer here at HashiCorp working on the Nomad project. Today we are going to have a discussion about running Nomad workloads at the edge, specifically configuring fault-tolerant, resumable workloads in edge deployments. So to sort of set the context, what are we talking about when we are talking about an edge deployment? Well, I'll refer you to this fantastic blog article written by my colleague Sarah, who will give you an in-depth overview of multiple use cases, but we're going to borrow a useful diagram from here. An edge deployment is essentially a deployment or a setup where your Nomad server cluster is running in one data center, and then your clients that are running workloads are somewhere else. It might be another availability zone, in the same region. It might be across the world in another data center entirely. It might be a hybrid setup where you got your servers running on-prem or in the cloud and your clients running vice versa. It could be a point of presence device or any other situation where there's a network segment between the Nomad servers and the client or clients that are running workloads. And Nomad's able to handle this type of a deployment pretty well due to our tolerance for high latency and network connections between the clients and the servers. The servers themselves communicate over the surf protocol, which requires a low latency connection between the servers, but with the clients, there's a much higher tolerance for a slow network connection. Historically, Nomad has dealt with a complete disconnect from a client, though, in a manner that is maybe not best suited for running an edge workload where you might expect, periodic interruptions of network connectivity between the control plane and the workers, or maybe you expect to have occasional consistency or occasional connectivity by design. For instance, a device that's on, a client that's running on a vehicle or something like that. In those sort of situations, connectivity with the control plane might be expected to be broken for long periods of time. What would happen historically is if a client lost connectivity for longer than its heartbeat grace period, the workloads on that client would be marked lost and stopped, and then when the client would reconnect, those tasks would be shut down. They might continue to run on the client for the entire duration of the disconnect, but then they would shut down as soon as the client reconnected, sort of as a matter of policy. We previously released a configuration option that you could set on your jobs that were running on clients, where you could tell them, hey, if you disconnect, go ahead and stop yourself if you remain disconnected for a certain amount of time, and run whatever shutdown configuration you have configured. And that setting was called stop after client disconnect, and you could basically tell the workload to shut down. What we're exposing now is a new configuration called max client disconnect, which is sort of the inverse lever that you can pull. And what this tells a job to do is, hey, or more accurately, tells the server to do is, hey, if this client running this task configured with this value reconnects within the duration you specify, just go ahead and reconnect and resume the workload. Don't shut it down. So we're going to take a little tour of some the existing behavior and the new behavior here over the course of the next 30 minutes or so. So let's start with taking a look at some job configuration. So this is a job. All the jobs in this demo are going to be named Edge. You'll see why in a minute. And in this particular job, we've got a simple task, and we have not configured max client disconnect or stop after disconnect on this job. More accurately, on the task group within the job. And so if we were to run this job, we're going to come over here. We're going to start a little watch on the cluster. And if we were to run this job, which has no max client disconnect configured, once it's deployed, we will simulate a network outage between the client node and the server node. So over here on the right, I've got a Consul open and I'm SSH'd into my client. And I'm just going to insert, we can see the deployment's complete down here where I issued the run command. We can look up here in the status, the watch I've got going on the status, and then we can see that everything's healthy, everything's running. So over in the client on the right-hand side, I'm going to simulate a network outage by inserting an IP tables rule that blocks traffic between the client and the server. And I'm going to go ahead and hit enter on that. And what happens if you're not familiar with Nomad architecture, there's a heartbeat mechanism that runs on a staggered 30-second interval where the agents will, check in with the servers and say, hey, we're here, and everything's good to go. And if that check-in process doesn't happen, historically, what would happen is the client, or the node rather, the client node would be marked as lost, and or down rather, and the allocations that were on it would get marked with stop lost. And if we look over here in the output of our watch, we can see that several of our allocations have transitioned to stop lost, desired status of stop, with the actual client status of lost, and they're all running on the same node, which just happens to be the node that I disconnected. And they got replaced. Some new allocations were spun up to make sure that the cluster stayed in the desired state. And then if we were to restore connectivity by removing that IP tables rule, nothing really is going to happen to those allocations. There's no way to recover them. They got shut down as previous behavior dictated. So we're going to go ahead and purge that job. And then we're going to take a look at our next job spec. And we're going to look at a basic deployment for a basic job spec that has this max client disconnect setting configured. And what I've configured here is a maximum of 2 minutes. If the client disconnects and reconnects within a 2-minute interval, then the jobs will reconnect and resume. While they're disconnected, the cluster, the servers will go ahead and deploy replacement allocations, just to make sure that the cluster has the capacity that's expected. Now, if you don't want that behavior, you can configure attributes, constraints rather, that will ensure that the job can't run anywhere other than a certain node, or you could configure reschedule configuration and control it through those levers. But in this case, I want to illustrate for you the full range of operations. So I've got this basic job, and I'm going to run it. And it's called spread, or I called the task, or it's actually called edge, but it ensures that we're going to spread our job equally across hosts within the data center. So we should end up with 3 on each of my clients that I have running. So I'm going to run that edge job, and it gets deployed. And as the deployment is running, everything looks good. We've got 6 that we desired 6 to be placed. 6 have been placed. Now we're just waiting for everything to check in with the control plane and let it know that it's healthy. And now we see that they are indeed healthy. Now, in this case, I'm going to once again simulate a connectivity loss, and that 30-second plus or minus timer is going to looping and looking for the client to check in. And once the client fails to check in, what's going to happen is the allocations running on that client are going to get marked as with this client status of unknown. And we can see that that happened right here. Okay. And then the nodes are now going to have a status of disconnected, the one that's just because it has a workload on it that can tolerate a reconnect. I'm going to go ahead and reconnect so that I don't hit my 2-minute barrier, but and we're going to watch what happens. So apparently we were in a really close to the threshold of that loop running, and my client checked back in, and the workloads that were on it went back to the running state. Okay, nothing happened. If we were to do a Nomad, they weren't shut down. If we do a Nomad status on that alloc ID, we can look real quick, and we will see that in the events on the task, we can see that a reconnect event happened, and the task was not shut down. And then the 3 replacements that had the newer timestamp, the newer created timestamp, those were actually shut down. So the cluster's back at the capacity that we desire, and the workload ran without any interruption. So that's good. Let's go ahead and purge that job and talk about our next use case that we're going to illustrate. So what happens if a job does expire while you're disconnected, where you reach that threshold before the client can reconnect? So I've got another job. It's basically the same job, but I've configured a much shorter 10-second duration. It can only tolerate being disconnected for 10 seconds. This may not be very realistic for your a real life workload, or it might be just depending on your use case. But in this situation, it's just optimized to allow me to illustrate behavior more quickly in the demo. So I'm going to run expired this job, and we'll see that it gets placed, and sooner or later, the deployment will complete, the tasks will be healthy, and as soon as the deployment completes, I'm going to go ahead and I'm going to trigger this IP tables rule again, and that is going to simulate again a disconnect, a loss of line of sight. That might be a router misconfiguration, a firewall misconfiguration, physical break in cable, whatever. The client and the server have lost the ability to see each other. The line of sight is gone, and connectivity has been disrupted. And like I said, it takes about a 30-second, runs on a 30-second plus or minus loop. And so sometimes, just depending on when you hit the button in the demo, it takes a little longer or a little less longer in some cases to see the transition of status happen. But in this case, we should get there pretty soon. And there we go. Once again, this client that I'm manipulating, C40, it now has 3 tasks on it that are running an unknown, and we can see that 3 replacement allocations were placed. And so now check that out. What just happened? These 3 on C40, they just transitioned to lost. Well, why was that? Well, because we said, hey, you can only tolerate a 10-second disconnect, and once that happens, please go ahead and stop those allocations, or at least at the server level, mark them as desired status of stopped and client status of lost. And then once it reconnects, what we'll see is here in a couple of seconds, this client status of lost is going to become complete. And what that tells you is the tasks will gracefully shut down once they reconnect, and they realize that the control plane no longer wants them to be running. And there we go. That transition just happened, so everything shut down gracefully, and we're good to go. So we will go ahead and purge that job. Now we're coming over to our next use case. And in this case, we're going to configure a job that fails. Why are we going to do that? Well, if you have a failed job on a client node that disconnects and it fails while the disconnect happens and then reconnects, you don't want to shut down these jobs, the replacement allocations that were running successfully in another client node. You want to just be able to detect that, hey, this didn't work right while it was offline. So I'm going to keep those replacement allocations and then just try to, basically acknowledge that the newly reconnected allocations are not running. So we're going to run that real quick, and we'll let that kind of play its little 30-second timer loop game after the deployment completes successfully. And there we go, the deployment has completed. So once again, we'll break the connection and wait for those to transition into a unknown state. And if we go back to the job spec, we'll look and we'll see just real quick, just to show you, they're gonna fail after about 30 seconds. That's what I've got a script injected in the job to configure to work that way. So here we go. Here are our 3 unknown allocations. Again, the client will show up as disconnected in the CLI output as well as the UI, because it knows that the cluster knows that it has workloads running on it that might be resumable. And so rather than calling that client down, we now call it disconnected. And so we'll go ahead and restore connection, and those should have failed. 30 seconds certainly should have expired, and it did, and we were really close to that barrier, that timer loop barrier. And you can see that those 3 are marked as failed, just like we would expect them to. So we'll just go ahead and purge those. And we'll come back to what is probably going to be our last use case that we'll be able to show right now. Maybe we'll have time. And what happens if I increment the job version, if I mutate the job somehow while one of the clients is disconnected? If I've changed the job definition, I would not want the reconnecting client's allocations to resume. I'd want to keep the updated allocations on different clients. And so in this case, if we look at job V1 versus job V2, what's changed is I've changed the image. I'm moving from Redis 3.2 on V1 to Redis 5.0 on V2. So we'll come over here and we'll run job V1 and let that deploy. And once that deployment is complete, we'll go through this same little dance again of simulating a network drop. Deployment's complete, so we will execute that network drop. And then once that happens, we'll go ahead and deploy an updated version of the job. We just need to make sure that these transition to unknown first and the replacement allocations get placed. Bear with me as we wait for that timer to fire. And the replacement allocations to get spun up. And there it goes. So we've got 3 unknown, 3 pending. Those 3 pending are now running. So that's great. So let's go ahead and apply version 2 of that job, which is a destructive update because it can't be made in place. It's not just metadata. And now what we'll see is that the new pending jobs for version 1 are getting placed. The version 0 allocations are getting marked for stop, and that'll take just a bit to complete. And once we get there, once that deployment is done, we will reconnect. And once the timer finishes firing, we should see that the reconnected allocations get stopped and shut down because they no longer have the most current job version. So we got 3 placed, 2 healthy, just sort of waiting, running all this locally here in a Vagrant environment with low memory, et cetera, just to kind of help with resource consumption. So it takes just a bit longer than it would on a production cluster, as I'm sure you can imagine. Got 4 out there. You can see them here, job version 111. The others are shutting down. And once we get to a point where all 6 are healthy and the deployment is complete, we'll go ahead and reconnect and watch what happens. We're almost there. Oh, here we go, 6 placed, 1 more to go to health check in, and the deployment should complete. And we are good, we're good to go, great. So now we've got 6 versions of 6 instances or allocations of job version 1 running. The others have been stopped, but we still got a few down here in this unknown status because the client is still disconnected and its timeout hasn't expired. So we're going to go ahead and reconnect it. And then what we should see happen is those unknowns will transition into a stop complete status as soon as they're able to reestablish connectivity. And there we go. They stopped and they're completed, and the cluster has the desired number of allocations running with the right job version. So we'll go ahead and purge that, and it looks like we are going to have time for one last use case here. We're going to, over in my IDE, I've got a canary deployment set up. Canaries are a way of doing updates where we roll out a little bit at a time, if you're not familiar with it, Google it, take a look at it on the internet. I'm gonna move quickly here for the sake of staying within our time constraints, but we're going to run our canary. We're gonna run the first version and get that deployment out. So that's running, and we'll queue up our network disconnect script over there. And once these are healthy, which they are now, we'll go ahead and we'll do our canary update. And what we're going to simulate here is what happens if a canary rollout gets interrupted by a client disconnect. And so I'm going to wait till we've got 3 canaries, let's say 3 placed and 1 healthy, and so that we are, kind of really in flight. Or I'm sorry, 2 healthy, and then we're really in flight. Things are kind of in an inconsistent state, and we don't know exactly, maybe some of the allocations are pending, maybe they're healthy, et cetera. So I'm going to wait for that to happen, for us to get to that stage of the rollout before I simulate the disconnect, just so we can get a really sort of chaotic state in place where a network disruption might really, put the feature through its paces. So we're just going to wait for that to run. All right. Bear with me again, running on a little bit of a nerfed environment to make sure that all the other resources necessary for recording, et cetera, have what they need. We've got one out there running, and that should finish. Should update here shortly. Well, unfortunately, I'm out of time. It looks like, so I am going to have to let you all, imagine how this is going to finish. But basically, what's going to happen with the canary deployment is it'll get to a certain point. We would disrupt the internet connection or the network connectivity between the client and server, just like we did previously, and what'll happen is, whatever's been deployed, the canary deployments get placed, and the network connectivity will be lost. It'll replace those canaries, and then what'll happen is it basically, if an allocation was part of a canary deployment, it will just get shut down rather than being brought back into the cluster. We just sort of assume that, hey, if we were in the middle of a canary deployment, that deployment wasn't really complete, go ahead and prefer the replacement allocations over the canaries, and keep trucking with those. So again, my name is Derek Strickland. I am so glad you joined us today. I hope that you found this useful, and that you will be running all your edge deployments on Nomad.